This video is over practicing verbal descriptions and turning them into functional equations. For number 1, it tells us the cost of a school banquet is $95 plus $15 for each person attending. We need to write the equation that represents the total cost as a function of the number of people attending. So our key word here is that it's $15 for each person. That word each is our key to be our M value, our rate of change. So we would have y equals 15x because m and x always go together. The $95 is the fee that you have to pay first before you can get into the banquet. So you pay the $95 fee and then $15 per person. Our equation, once you put in both pieces of information, is y equals 15x plus 95. When it comes to actually solving the equation, you use the equation you used, the one we just made, 15x plus 95, but we plug in the value given, 77. So we're going to do 15 times 77 because it's $15 per person and we have 75 people. 15 times 77 is 1,155 plus the $95 fee is going to be $1,250. That is our total for 77 people. Number 2, Roman paid $150 to join a handball club. He pays an additional $15 every time he uses one of the club's handball courts. So for letter A, we want to write the equation. Again, our key word is this word every, $15 every time. So that's going to be our 15x, our mx values. The initial value is what he paid first. He had to pay $150 to join and then $15 each time to use the handball court. We're going to use that equation, y equals 15x plus 150, in order to write our equation solving for the value of 33 times. So we're going to multiply our 15 by our value 33 as given in letter B. And when we multiply 15 times 33, we get 495 plus the $150 fee is a total of $645. Number 3, a sunflower in Julia Rosario's garden was 12 centimeters tall when it was first planted. Since then, it has grown approximately 0.6 centimeters per day. Again, our key word is that per day. Per and each and every is represented by the rate of change, letter M. So our equation starts off as y equals 0.6x, 0.6 centimeters per day. Our B value is our 12 because that's how tall it was when it was first planted. In the beginning, it was 12 centimeters tall. We're going to use that equation, y equals 0.6x plus 12, and we're going to solve it for our 15 days. So we're going to plug it in. It's 0.6 times 15, 0.6 centimeters each day. So for 15 days, 0.6 times 15 is going to be a total of 9 centimeters, plus the original 12, because it was already 12 centimeters tall, gives us a total of 21 centimeters tall. Number 4, David is going kayaking with friends. It will cost $36 plus an additional $11 per hour. So our key word is our per hour, which is our rate of change. So our equation starts off with y equals 11x, $11 per hour. The plus b value is going to be the $36 fee that we have to pay first before we can go kayaking. We're going to use that equation, y equals 11x plus 36, in order to plug in the value that we're solving for, 4 hours. It's $11 per hour, so 11 times 4 would give us 44, plus the $36 that we have to pay up front. You add those together, 44 plus 36, to give us a total of $80. For number 5, Billy plans to rent a booth at a craft show. The booth costs $50. He plans to sell baskets for $7.25 each at the show. write an equation that gives the total profit as a function for the number of baskets sold. So again, our rate of change is going to be the 7.25 each. And so we can write our equation as y equals 725x, because m and x always go together. Our initial value is going to be the $50 that he has to pay first. Now, this is going to be a negative 50 because Billy is paying money to get the booth, but he's making money with the 725. So that's why that negative is 50, because we are paying $50. So for letter B, we're going to use that equation to make our profit of 9 baskets. So we're going to do the 725 times 9 to figure out how much money we make from the baskets. When you multiply those two values together, 725 times 9, you end up with 65.25. Then subtract the $50 that Billy had to pay for the booth, and so he made a profit of $15.25. For letter C, it says he's only selling 4 baskets. So we're going to use the same equation, but instead of putting in the value 9 like we did earlier, we're going to plug in the value for 4. So we're going to multiply the 725 for the 4 baskets, which gets us $29, minus the $50 that we had to pay, gets us a total of negative $21. So when to ask the question, will he make money? The answer is no, he won't, because we are negative $21. Number 6, Felicia paid $125 to join a tennis club. She pays an additional $5 every time she uses one of the club's tennis courts. So for this problem, it says that we have to spend $5 every time. That's our key word for our rate of change. Y equals 5x. Our initial value is the $25 that she has to pay first. She joins the club for $125 first, then she pays $5 each time that she goes. So that's our equation. So for letter B, it tells us that she does not want to spend more than $275. So we need that to be our total, $275. And so we need to figure out what that missing value is. How many times can she play tennis? So when we are solving this problem, we work backwards. Instead of the plus 125, we do a minus 125. 275 minus 125 is going to get us to 150. The 5 and the x side by side means multiply. So again, we do the opposite, which is divide. 150 divided by 5 is going to give us 30. She can play 30 times and not spend more than $275. Number 7, the graph for a stable that charges a $20 flat fee plus $10 per hour for horseback riding is shown below. So as you can see, it starts down here at 20 and it goes up 10 over 1, up 10 over 1, up 10 over 1. It follows that pattern. It's going to change. It says the stable changes its charges to a flat fee of $30, so that means we're starting at the 30, and it's doing $20 per hour, so up 20 and over 1. What will happen to the initial value and the rate of change? Write and graph the new equation to represent this. So again, our new equation is our $20 per hour for our letter M, so that's 20x, and our initial value of the $30 fee. It compares to the original equation of $10 per hour, so that's the 10x, and the original $20 fee. So the rate of change goes up. It's going up from the $10 per hour to $20 per hour. The initial value is also going up. It's going up from the $20 fee to the $30 fee. Number 8. Suppose you will receive $250 for a graduation present and you deposit in a savings account. Then each week thereafter, you add $15 to the account, but no interest is earned. The amount in the account is a function of the number of weeks that have passed. So again, we're doing each week, we're doing $15. So that's going to be our letter M, $15 each week. The $250 is what we started with. We started with the $250 in the bank, and then we're adding $15 each week. Now, we want to use that equation, y equals 15x plus the $250, and figure out how many weeks does it take to get a total of $730. So again, $730 is our total. We're missing the number of weeks. That's what we're trying to solve for. Solving equations mean we work backwards. So instead of plus 250, we do the opposite. We do a minus 250. 730 minus 250 is going to give us a total of 480. Then we can divide by our 15 to figure out that our weeks would be 32 weeks. It takes us 32 weeks to save up $730. Number 9, John was renting a limo. It cost $75 to reserve the limo and an additional $36 per hour. Our key is the $36 per hour. That's our rate of change. So that's the y equals 36x. Our initial value is the plus 75 that it costs to reserve the limo first. We're going to use that equation, y equals 36x plus 75, in order to solve for the number of hours given, 6 hours. If it's $36 for 1 hour, we're going to multiply those numbers together, 36 times 6, which gets us 216. Then we can add on the $75 fee that we pay first, and it gives us a total of $291. Nick is going on vacation. He spends $1,453 on the flight, hotel, and rental car. He decides to spend $75 a day. So for our equation, our key word is the $75 a day, because that's per day. That's our rate of change. So 75x. Our initial value is the money that he had to spend first in order to book the hotel, the flight, and the rental car. Now we're going to use that equation, y equals 75x plus 1,453, in order to plug in our value of 6 days. Remember, he's spending $75 each day. So we can multiply the 75 times 6. That would get us 450. Plus the 1,453 that he spent on the hotel, rental car, and flight, for a total of $1,903.